EDX Mechanics 1, collisions in one dimension, Newton's law of restitution. In a collision between two objects, we assume that there is no external force acting on those objects, and we consider what's called the momentum of the particles, and the momentum depends on the masses and the velocities of the two objects. However, we can also consider the elasticity of the objects during the collision, and the elasticity of the collision is found through an experimental approach, and it forms what is known as an experimental law. Restitution is the measure of how elastic the collision will be and is a property of the combination of the two materials involved. We measure restitution using what's called the coefficient of restitution, little e. So Newton's law of restitution relates the restitution value E to the relative speed of the objects before and after the collision. So the law states that E equals the separation speed between the objects divided by the approach speed between the objects. The coefficient of restitution is always dimensionless and takes on a value between 0 and 1. If the experimental value of E is 0, then the collision is totally inelastic and the objects will stick together or coalesce. However, if E equals 1, then the collision would be perfectly elastic. So we've got an example here of two objects which are going to collide. There are no external forces acting on them, and we need to calculate the coefficient of restitution for this combination of materials. So there is a single value of E which will create these velocities after the collision for these two objects. So E is the separation speed over the approach speed. It's very important when you're doing the separation speed and approach speed that you look at the velocities on your diagram. So you must take into account the direction of the arrows. So if the separation speed first, if B is moving to the right at 4 meters per second and A is moving to the left at 1 meters per second, then they are leaving each other at a relative speed of 4 plus 1. They're separating from each other at 4 plus 1 meters per second. However, if we look at the approach speed, A is moving to the right at 5 meters per second, B is moving to the left at 2 meters per second, so they are approaching each other at a relative speed of 5 plus 2. They're moving towards each other at a high relative speed, which gives us a coefficient of restitution value of 5/7. During this collision, we are told the coefficient of restitution is 3/4, but we don't know the velocity of A. I've made an assumption on my diagram that A will move to the right, so I've put the arrow to the right. If that proves to be wrong, then we will end up with a negative answer for V. So don't be too worried about assuming an object moves in a particular direction. If you make a mistake with the direction, you will get a negative answer. So my assumption is it will move to the right. So applying Newton's law of restitution, we have E is given as 3/4 equals the separation speed. Now if B is moving to the right at 4 meters per second and A is moving to the right at V meters per second, V must be less than 4. A cannot be travelling faster than B if they're both travelling to the right. So the speed of separation is the bigger 4, take away the smaller V. The approach speed, if they're travelling towards each other, that's a high relative speed that they're travelling at towards each other, so their approach speed is 6 plus 2. So that gives me 8 times 3/4 is 4 minus V, or V equals minus 2 meters per second. So If the velocity is minus 2 meters per second, that means that the arrow was indeed pointing the wrong way and that A will rebound to the left. So we can either say the velocity is minus 2 meters per second, or we can say that the speed is 2 meters per second and that it is moving left, to make it absolutely clear that it has rebounded at 2 meters per second. And we can see the method again there. In this example, we have a mass of 4 kilograms collides directly with mass B, which is 3 kilograms as shown. We need to find the resultant velocity of each of the masses after the collision. We know they are travelling towards each other as shown. We know that the coefficient of restitution is 2/5. We don't know their velocities afterwards. So I am going to make an assumption that A will keep on going with a velocity of v1 and that B will end up moving to the right with a velocity v2. And if those decisions are wrong, I would expect a negative answer. So starting off with Newton's law of restitution as my first method. So we've got E, which is given as 2/5, is the separation speed. Now if they are both moving to the right as v1 and v2, v2 must be a little bit bigger than v1. A cannot be going faster than B if they've just collided. So their separation speed must be the bigger v2 take away the smaller v1. Their approach speed, however, if they're travelling towards each other, that's a high impact speed, so the approach speed is 4 plus 6. So simplifying that gives me v2 minus v1 equals 4. So that's my equation 1. I can now do conservation of momentum. Now we're dealing with vector quantities. I need to make it clear that I'm going to take the right as positive. Momentum is a vector quantity, remember. So we're going to do final momentum equals initial momentum. So let's start with the initial momentum. We've got 4 kilograms moving to the right at 4 meters per second, so that's a positive 4. And we've got 3 kilograms, but that's moving to the left at 6 meters per second, so its velocity is negative 6. After the collision, we've got 4 kilograms moving to the right with a velocity v1, and 3 kilograms moving to the right with a velocity v2. So that simplifies down to 4v1 plus 3v2 equals minus 2. And if I solve these simultaneously, I get v2 is 2 meters per second. So that's its velocity, is 2 meters per second, which means it does indeed keep rebounding and bounce off to the right. And v1, when I do the simultaneous equations, is minus 2 meters per second of velocity, which means that if the arrow on the diagram is to the right and we've got a value of v1 which is negative, it must have a speed equal to 2 meters per second, and it has indeed rebounded and it's moving to the left. It's not moving to the right following B, it's rebounded and going off to the left. And we can see the full method there. In the next session we're going to be looking at loss of energy during the impact.